In this video, we are going to talk about the underlying calculations of f280 inside Studio. It's really important and helpful for you to know what happens when you press the simulate button and where do these numbers come from. And one of the best exercises for me to better understand and also convey where the calculations come from is to try to get this number, the heating load or the cooling capacity or load that you see inside the report, to zero. Get these numbers to show zero. And that way, by removing each component of heat load or cooling load, we are going to be able to better understand where those numbers come from. You may remember that in one of our previous videos, we mentioned the project details page, and this is where one of the first components of the load is coming from, and that is the air tightness. If your building is leaking a lot of air, well, guess what? You have to compensate for that lost air in the heating and cooling season. So I'm going to go ahead and set this air tightness to 0.01. I try to avoid number 0 because that may confuse the model. This number is pretty low and it's very unrealistic, but here it helps us to remove the components of air leakage for the sake of the practice we want to do. So I press save, and if I press simulate, I will notice that my numbers have slightly changed, slightly come down. Now, let's talk about another component of heating and cooling load. Well, specifically in this case, cooling load. And if I go to design conditions, which we also talked about, and that is the number of occupants. Occupants generate heat, and you have to address that heat using cooling. So if I put the number 0 for my number of occupants and I press save, it is going to help slightly reduce that number. Okay, next up, you remember that we talked about different kinds of adjacencies. So these walls, if they're adjacent to exterior, they will get accounted for inside the model. And we did the work to make sure that all of them are part of it. Now, let's start doing the opposite, and let's start setting different components of the building to be adjacent to interior. So I'm gonna start with foundation. I'm just gonna say it's adjacent to interior. I'm also going to do 3 walls. I will keep 1 wall adjacent to exterior just because I want to not create too much of an unrealistic condition for the model, and you may see that you may not be able to get results from that. Same with ceiling. I'm going to change it to interior, just basically undoing the things we did in our previous steps. And I also mentioned this ventilation component here. I can just simply go ahead and delete it. And this way, if I go to my table view, I see the things that I didn't want to see in the previous video, which is that we don't really have a whole lot of components that go in the model, except for this one wall. So let's press simulate and see how things change. And you will notice that our number here is 358 for heating capacity and a very small number for our cooling capacity. Now, if I select this wall, I will see the parameters of area of this wall and this R value, and I can understand that these components are generating that 358 BTU. But we can go one step further than that, and we can actually calculate with hand manually for this one wall, which is a simple north-facing wall, where that number is actually coming from. Those of you who are familiar with heat transfer formulas have seen this as a very common calculation method being used, which is that the amount of heat loss we have from one surface is equivalent to its U value times its area times its delta T. And in this case, delta T is the difference between the temperature from the inside versus the outside. I like to write this formula as area times delta T divided by R, which is, R and U are just the opposite ends of one another. And this makes it a little bit easier to plug in the numbers. The only thing that I really have to keep in mind is that all of these inputs, they need to be the same unit. So if area is square feet, temperature needs to be Fahrenheit, and R value needs to be imperial R value. So let's go take a look at the wall that we just had. So our area is 95.7 and our R value is 14. Now, where does the delta T come from? If your intuition was that this is coming from the design conditions tab, you're absolutely right. This is where you can get the delta T, which is -7 for outdoor air temperature and 22 for indoor air temperature. And if I plug these numbers here, but in Fahrenheit format of them, and if I use this formula, I will get a number that is very, very close to 358, if not the exact number. And that is how this number is calculated. Of course, in an actual building, things are a lot more complicated than that. There are a lot of building elements that are interacting with one another. Here we only kept one wall for the sake of argument and for the sake of simplifying the model as much as possible. We removed the air tightness component completely. Keep all of those things in mind, but this is a really good exercise to better understand where the numbers are coming from. As for getting the model to actually reach zero, that's also possible. For those of you who are keen-eyed, you realize that any of these components, if I change them, I can get the model to actually not show a whole lot of heat transfer. So for example, if I go to my construction and set a custom R value and put a very high number for it, a ridiculously high number, and press simulate, you will notice that now my heat gain and heat loss numbers are actually zero, because there is really not a whole lot of heat that is being escaping or entering this room. I could do it another way. I could set this to 14. I could modify the area, but also I could do the same thing with delta T. I could go to my design conditions tab and I could set the outdoor design temperature to 22 degrees. That means we are telling the software the coldest temperature that this wall is ever going to see is 22 degrees. And the indoor air temperature is 22 degrees. So there won't be a whole lot of heat loss and heat gain from these surfaces. And what you will see is that our heating load is zero. There is a nominal cooling load here, and that's just because we only changed the heating design conditions. It's a good exercise to play also with design conditions for cooling, but I leave that to you. You will notice that this one is a little bit more tricky, especially when you consider occupants, the solar gain from the windows, and also the plug loads for rooms such as the living room or the dining room. But always, it's a good exercise for you to remove and add things, change numbers and modify them, press the simulate button and see how those numbers change the results.